All right, geometric sequences. Yesterday we started with arithmetic sequences where you were given a sequence, meaning a pattern, right? A set of numbers that form a pattern, and what did you have to do to get from one number to the next? Add. Now, geometric sequences is similar, except this time, if you look closely, what are we going to be doing instead of adding? Multiplying. And since we are multiplying, it is no longer called the common difference. It is now called the common ratio. So you're going to use the variable r instead of the variable d. Okay? Still writing an explicit and recursive formula. The easier part about today is that you don't have to simplify your explicit formula. All you do is plug in numbers for your a sub 1 and for your common ratio. Okay, you plug in your numbers, move on with your life. And we are going to write our equations in recursive form, but like I said yesterday, it doesn't help you find the nth term, so we don't really use it. Okay. All right. So part A, it says tell whether each sequence is geometric or not. If it is, state the common ratio and write the next term in the sequence. So how do we get from 2 to 8? Times 4. And then 8 to 32 times 4. 32 to 128 times 4. So is this a geometric sequence, yes or no? Yes, where the value of r is 4. Now, to find the next term in the sequence, all I have to do is take the 512 and multiply it by 4 to get 2048, which is, how do we write that though? How do we write our response?
AN equals...
Not AN, A sub 6. A sub 6 to represent that this is the 6th number in the sequence. Okay? Questions on this one? Number 2. What do we do to get from 1 to 4? Times 4. But then 4 to 9? Plus 5. 9 to 16. Is this a geometric sequence? No. We can go ahead and move on. Number 3. If you look at those numbers, you notice that those numbers are doing what? They're decreasing, meaning they're dividing. So to get from 81 to 27, we divide by 3. But the common ratio is based on the multiple, the factor. You can't, your value, your common ratio, your r is not 3. What? Dividing by 3 would be the same as multiplying by what? Multiplying by 1/3. Now, some students forget that those are equivalent, that they are the same thing. So let's go through those steps, right? For example, 9 divided by 3 is 3. Now compare that to multiplying 9 times 1/3. When you multiply a whole number in a fraction, what do you do to the whole number? You turn the whole number into a fraction by putting a 1 under it. And then when you multiply, do you multiply diagonally or straight across? Whoa! Straight across. So 9 times 1 is 9. And then 1 times 3 is 3. Then you have 9 divided by 3, which is... So once again, as a quick recap, dividing by 3 is the same as multiplying by 1/3. So just to solidify, dividing by 4 is the same as multiplying by... Dividing by 5 is the same as multiplying by 1/5, so forth and so forth. Good. All right, you guys get it. Part A. Is this a geometric sequence? Yes. What is our common ratio? 1/3. So to get the next term in the sequence, to get a sub 5, I multiply by 1/3 or divide by 3, and I get 1. Number 4. What do you notice is different about this pattern, about this sequence?
It's going from negative, positive, negative, positive.
So what must we multiply by in order to flip-flop our sign every single number?
Negative.
Multiply by a negative. So -5 times what?
-5. No.
-3. Oops, times -3. Then 2 negatives make a positive. Now 15 times -3, positive times a negative is a negative. Okay? So is this a geometric sequence? Yes, with our common ratio being -3. And to get the next term, to get a sub 6, what do we get?
1,215.
Questions so far? All right. Part B, write a function for each sequence in explicit and recursive form. So for number 1, part A is asking us for what digit? The first number in the sequence, which is 2. Now, R is our common ratio, the number that you are multiplying, which is
6.
You multiply by 6 every single time. Explicit form. Like I said earlier, this one with geometric sequences, you do not have to simplify it, so it's a lot easier, but you do have to plug numbers in correctly. So we're going to write the formula first. A sub n is equal to A sub 1 times R to the power of n minus 1. You're doing this one. So, this one goes with those notes. After you do that, you just watch the video on this. There's no.
What is this?
That's it, assignment. That goes with this.
Oh, it's the notes.
Yeah. It says notes.
Oh, I didn't even see that.
All right. So the only spots that you plug numbers into is where you see the A1 and our common ratio. So our formula will be A sub n. That's why I gave you the headphones. A sub n is going to equal what? 2 times 6 to the power of n minus 1. Recursive form, the formula is A sub n equals R times A sub n minus 1. All right. For the recursive formula, you just have to plug the common ratio into the correct spot. Everything else is the same. So that's even easier to form. So you get A sub n is equal to what? 6 times A sub n minus 1. That's it. Part E is asking us to find which term in the sequence. The fifth term. So you plug in a 5 where you see n. You're going to plug in a 5 in your exponent spot. Now, the only thing that a lot of students mess up on is they forget about that minus 1. So make sure it's 5 minus 1 in your exponent, as your exponent. What do you get?
2,492.
So A sub 5 is 2,592. Very good. Questions? All right. Number 2. What are we multiplying by to get from one number to the next?
3.
We're multiplying by 3. The first term in my sequence, A sub 1, is -5. R equals represents my common ratio, which is 3. Now, writing this in explicit form, we get A sub n equals what? -5 times to the power of, yeah. Recursive form, A sub n equals parentheses 3 times a sub n minus 1. A sub 6 represents the sixth term. So you plug a 6 in your exponent spot. Do not forget the minus 1. What is your results?
Negative 45.
You forgot something. Whoa, what'd you get?
I don't know if this is right, but I got negative 7,290.
Also not correct. Am I typing this in wrong? Am I going? No, y'all aren't typing this incorrectly. Y'all are making me feel dumb right now. But no, that's not the answer. It's you're typing in negative 5 times 3 to the power of 6 minus 1. Negative 1,215. Okay. Man, sometimes y'all say some answers that make me question myself. 12, 15. Which I have been wrong from time to time, but not this time.
Oh, I saw it.
What'd you do?
I added. Yeah, I put 6.
You-
I put 6 in the front on accident instead of putting it in the back.
Oh, okay. All right. Questions. Number 3. Our numbers are
Multiplying.
descending, so that means we're technically multiplying by a fraction. What fraction are we multiplying by?
No, it's not 1/5.
Who said 1/5?
Josiah.
No, it was Josiah.
We're going to send you back to math. 1/2. 1/2. All right. A sub 1, first term in the sequence is 80. Our common ratio is 1/2. Writing this in explicit form, a sub n equals what? 80 times 1/2 to the power of n minus 1. Recursive form, a sub n equals parentheses 1/2 times
A sub n minus 1.
a sub n minus 1. Part E is asking us to find the 7th term. To find the 7th term, plug in a 7 in your exponent. Don't forget the minus 1.
Miss, you ready for this ball knowledge? It's 1.75.
Whoa.
It's 5 4.
We're sending you back to math this time. 1 point what? Now, if your answer is in fraction form, what is 1.25 as a fraction?
5 4.
5 over
I was
4.
thinking 0.75 is 1.